So what you're looking at right now is the definition of the derivative, and it should look familiar. We have f of x plus delta x minus f of x. This is a change in y over delta x. Change in y over change in x. It is a slope. Now, this piece is the slope of the secant line. When we add the limit as delta x approaches 0, we're taking our 2 points that we found the slope with and making them very, very close together, the distance between them becoming negligible. So it becomes the slope of a tangent line, which means that f prime of x, and this little prime symbol here is how we denote a derivative. It's one way to denote a derivative, is very simply the slope of a tangent line. So when people talk about derivatives, that could be what they're talking about. There are other ways to write it. Instead of using delta x, some people use h. So they'll say the limit as h approaches 0. And then the formula follows the same way. It would be f of x plus h minus f of x over h. So this is a simple substitution. Another way to write it is actually if you looked at 2 points like this. You have a, f of a, and then our generic point x, f of x. So if we look at this and I write the slope formula, I might start with my f of x. So f of x minus f of a over x minus a. So I have 2 points, and for this, so this is a slope of a secant line. If I want it to be a tangent line, then I would say that I'm going to take the limit not as a approaches 0, because that just takes a point and heads it towards 0. It doesn't get it closer to a. So what I'm going to do instead, let my x value approach a. So here's your graph, here's your a, here's your x, and I'm going to move my x closer and closer to a, which is the same thing as shrinking the delta x between these two down to 0. So we have this way to write a derivative. We have this way, which is the same exact thing, except the delta x's have been replaced with h's, or you can look at it and this looks a little bit more like the slope formula. All of those are correct. Now, notations for derivative. We know we have f prime of x. That would be for the first derivative. You can also say it's the derivative of y with respect to x, so you might see that it looks like this. Some people just say if you have y equals, you're going to end up with y prime equals. If it was x equals, it would be x prime. Another way would say we're going to take the derivative with respect to x, so it looks like this one, but we didn't have a y equals. Instead, we had an f of x equals. So they would say of f of x. So the derivative with respect to x of f of x, the derivative of y with respect to x, y prime, f prime of x. You could do this, the derivative with respect to x of y. You can see that this is all the same. Now, these are my favorites because they actually give the most information. They tell you which variable with respect to. This one does it as well, right there. Y prime, you just take the derivative of whatever you have. It could be in terms of t, something else. You never really know. So these are all different notations for the derivative. Now, actually, taking a derivative is called differentiation. You could also say take a derivative. But this is the process of taking derivatives. So if you can take a derivative, that function is called differentiable. And that would be if the tangent line actually exists where you're looking. So this is the just derivative basics, what's going on, but it is the definition of a derivative right here. That's the formula. It is the slope formula. It is the slope of a tangent line.